All right, in this video, we are going to be talking about trig limits, and to evaluate these, what we are going to be doing is looking at the trig limits that we found earlier using our table of values right here. So we have sine x over x, that's going to be 1, and then 1 minus cosine of x over x is going to be 0 as x approaches 0. All of these are going to be dealing with x approaching 0, so we are going to be using some properties here for these right here. So I'm going to just say that limit as x approaches 0 of sine x over x will give me 1. And then the limit as x approaches 0 of 1 minus cosine x over x is going to give me 0. These are going to be two trig limits that you probably need to memorize for the quiz and the test. So here, I have tangent of x, so what I'm going to do is think about, I know that tangent is the same thing as sine over cosine. And then what I'm going to do is manipulate this because I have sine x over x. So now I have the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over cosine of x. So I'll just split this up right here. I know that sine x over x is going to approach 1, and then if I were to plug in 0 for cosine here, that's going to give me 1. So 1 times 1, which is giving me a limit of 1. Okay, for sine of 4x over x as it approaches 0 right here, what we want to do is make sure that my argument is the same. Notice how here my argument is the same. So because my argument is 4x, I want to make sure that my bottom also has a 4x. Well, in order to do that, I'm going to multiply by 1 in terms of, let's say, 4 over 4. And the reason why is because then my argument is going to be the same. So now I have this right here, sine of 4x over x, which is going to give me 1 based off of this limit right here. And then I have 4, so 1 times 4 is just going to give me 4. All right, same thing for this one right here, tangent square of x over x. So once again, I know that I'm going to have sine square of x over cosine square of x, and then I have 1 over x. I'm going to go ahead and move this so that it looks like this right here. Now, here's the thing about this one right here, because I have sine square of x. What I want to do is essentially figure out how can I make sine x over x with a square. So this is my end goal, so that I can take out the square. Well, in order to take out the square, I'm going to need an x squared right here. I have an x. So what I'm going to do is go ahead and multiply by 1 using x over x, so that this x right here in the denominator goes with this right here. And this is going to give me this right here. So that's my first part. Now I have x over cosine square of x. So I have the limit as x approaches 0 of sine x over x squared times the limit as x approaches 0 of x over cosine square x. Now, if I were to plug in, well, we know that this is 1. And if I were to plug in this right here, I'm going to get 0 over 1, because cosine square of 0 is just going to be 1. So I have 0 over 1, which is 0. So then I get 1 times 0, which is just going to be 0. Now, it is important to note that this right here is not indeterminate, okay? Not indeterminate, because I literally have a 1 in the denominator, even though I have an answer of 0, which is valid, but it's not 0 over 0. So here my answer is just 0 because I have 1 times 0. Likewise, we're going to do the same thing for this one right here. I have the limit as x approaches 0 of sine x over x, and then the limit as x approaches 0 of 1 minus cosine x over x. And then I have the limit as x approaches 0 of 1/2. Since I just broke down my denominator to be x times 2, or 2x squared right here. Okay, so sine x over x, we know that's just going to be 1. We also know that 1 minus cosine x over x is 0. And then this right here is just a constant of 1/2. So I'm going to get a limit of 0. This limit right here is very similar to the limit at the top right, sine of 4x over x, where I just got to make sure that this right here has an argument of 7 instead of a 4. So what I'm going to do is go ahead and multiply by 7 over 7, flip-flop this, so that I have the limit as x approaches 0 of sine of 7x over 7x times 7 over 4. This right here is going to give me 1, and then 1 times 7/4. It's just going to be 7/4. All right, this one right here, I have sine square of 5x over 4x squared. Now, because I have a square, I need to figure out how can I get a square here. So if I do this right here, sine of 5x over 5x, I know that this limit is going to be 1. But in order to do that, I need to figure out what my denominator should be. So if I were to simplify this, I need my denominator to be a 25 because 5 squared is 25. So I'm going to multiply by 25 over 25 such that I get the limit as x approaches 0 of sine square of 5x over 25x squared times 25 over 4. That way I could take out the square so that I could get sine of 5x over 5x squared. I know that this is going to be 1. 1 squared is just going to be 1. And I still have my 25 over 4 left over. So my answer here is 25 over 4. All right. Last topic for this one, and then we'll talk about limit laws in the next video. We have the squeeze theorem, which is also called the sandwich theorem. So essentially here, what we're going to do is think of two functions, and we are going to squeeze, and we're going to have another function, and that function, in this case f, we're going to fit this function into function g and function h, so that the limit of g and the limit of h will also be the limit of f at that point, in this case at c. Here's some little mumbo jumbo. So if h of x is less than f of x, which is less than or equal to g of x, then all of that gives us, that mumbo jumbo. So what we're going to do here is find two functions that will squeeze the following, and then find the limit. We're going to be using Desmos. So I'm going to do the first one, where I have x times sine of 1 over x. So I have x times sine of 1 over x. So we have this mess right here. Now I want to approach 0 right here. So as I look and I get closer and closer and closer and closer and closer, I get this mumbo jumbo right here. But you'll notice something very special about the non-shaded boundary. It kind of looks like the absolute value of x and the negative absolute value of x. So what I'm going to do here is use these two functions right here and take the limit of that. So as I take the limit of the absolute value of x as x approaches 0, and the limit of a negative absolute value of x as x approaches 0, you'll see that it's going to approach 0. So this tells me that based off of this right here, the limit of x times 1 over x times sine of 1 over x as x approaches 0 is going to give us 0. Based off of, let's say, the limit as x approaches 0 of the absolute value of x, and the limit as x approaches 0 of the negative absolute value of x. Now we can do the same thing for the second one, 6 minus 6 cosine of x over x squared. So I have 6 minus 6 cosine of x over x squared. And I have this right here. You'll notice that here it kind of looks like a parabola. And we have this right here. So I could say y is equal to 3. That could be a function that we could squeeze through. And then we can also say negative x squared plus 3. We could squeeze that, because you'll notice that this function right here is always going to be greater than this purple function right here. And then the red function, aka my negative x squared plus 3, will always be less than my purple function. So we could squeeze that. And then if I were to squeeze it, you could see that my limit will approach 3. So I could say the limit as x approaches 0 of 3 gives me 3. And the limit as x approaches 0 of negative x squared plus 3 equals 3. And then based off of that, I could say that this limit will approach 3 using the squeeze theorem. All right, in the next video, we'll talk about limit laws, and then that's it for limits numerically, graphically, and algebraically.